Today we're going to take a look at moments. What is a moment? What's the difference between work and a moment? Let's take a look at what work is. It's a force times a distance, where the force and distance are parallel to each other. So, for example, a person is lifting a box. And in this case, the forces of gravity and the force of the person lifting are vertical, and distance moved is also vertical. So as you can see in my graphic, the forces and the distance moved are parallel to each other. It's not just gravity, it could be forces in any direction. For example, we have a person pushing a table. Force is this direction, and the distance traveled, and the distance and the force are parallel to each other. This is work. Was it that moment that we looked into each other's eyes? Okay, now let's take a look at moments. A moment is also force times a distance, just like work, except the force and the distance are perpendicular to each other. Take a look at this graphic. Here we have the person holding out the stick, and on the stick is some weighted object. In this case, force is going down due to gravity, but the distance is perpendicular. For this experiment, I just found a scrap piece of wood in the garage. Doesn't really matter. Something that I can hold on to. It's fairly lightweight. And a rock. Somebody gave me this rock. So we're going to use these two things and write down our data. Let's see what we got. 270 grams, or 0.27 kilograms. We know that a moment is equal to force times distance. In the metric system, force is measured in newtons. Distance is measured in meters. When you multiply these together, your unit is newtons times meters. That's an N. Our rock weighed in at 0.27 kilograms, or 270 grams. But we can't use that. We need newtons. And so in order to create newtons, I have to multiply this by 9.81. So multiplying the mass in grams times 9.81 meters per second squared, this is the acceleration due to gravity. When you multiply those together, you come up with a force in newtons. How does that work? Well, this is another one of those situations where Isaac Newton came up with this formula. So this is Newtonian Physics. So by definition, meters per second squared multiplied by kilograms equals a newton of force. So I'm going to take my stick. I happen to have a flexible tape measure here. You can use anything you have. See what you can find at your place. And unroll this thing, and I'm going to put a mark, the 0 mark where my thumb goes. Then I'm going to go down to 25 centimeters and put a mark on there. And then I'll go down to 50, put a mark there, and 70 is pretty much the end of my stick. So I have markings where I'm going to place the rock on my stick. How does this experiment work? Keep your elbows down, be able to hold your board out like this, and then place your mass on the board. I currently have my mass placed at 0, so let's calculate the moment. Here I have my rock placed right where my hands go. So we're going to calculate the moment equals force times distance. Force is 2.65 newtons, and the distance is 0 meters. The moment equals 0 Newton meters. There is no moment. Now I'm going to place my mass at the 250 millimeters, which is 25 centimeters, and hold it. Wow. That's a little bit more difficult. Not too bad, but I can feel a difference. Let's calculate the moment. Now I have my rock at 0.25 meters. Let's go down here. Moment equals the force, 2.65 newtons, times 0.25 meters. The moment is equal to 0.66 Newton meters. Newtons and meters are multiplied together. And now we're going to move this out to the 500 millimeter mark, which is 50 centimeters. Oh, that's quite a bit more difficult. So let's take that force times distance and calculate the moment here. At half a meter, or 50 centimeters, or 500 millimeters, place my rock. The moment is equal to 2.65 newtons times 0.5 meters. That equals 1.33 Newton meters. Finally, we're going to move out to the very end of the board. Let's go do a calculation. Finally, I put my rock out to the end, at least I try, and that moment is equal to the force of 2.65 newtons times the distance 0.7 meters. That moment is equal to 1.86 Newton meters. You could work this same thing out in English units. Your force would be in pounds and your distance would be in inches, and your unit for moment would be pound inches or inch pounds. I hope this video helped you with your understanding of mechanical moments. Thanks for watching. Have a good one.